All right. So if we look at this, we have a tape diagram here that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, partitioned into tenths. And recently we have been shading in one of these and writing it in fraction form, which would be 1/10. And we've been turning that fraction form into decimal form, which looks like 0 whole pieces, or 0 ones, and 1/10. Now today we're going to take our tape diagrams, and we're going to take our knowledge about tens, and we're going to show why in decimal form 1/100th is written as 0 ones, decimal point 0 1/100th. We're going to show why this 0 matters, why it's so important. So we're going to use meters and centimeters to model the decomposition of one whole into hundredths. And then we're going to represent and count those hundredths. Now, I have set up some slides to where we don't have to partition everything all the time. But we are going to show why this 0 is so important. So let's just go over it one more time. We have been working with a fraction like this, 1 shaded in piece out of 10 total pieces. So our fraction is 1/10, and we write that as a decimal. We would write that as 0 ones, because we haven't shaded in one whole piece, a decimal point, and 1/10. Using something like this, we're not going to use this one quite yet. Right here, this is what we're going to call our meter stick. And it takes 100 centimeters, 100 centimeters to equal 1 meter. So right here I have 1 meter. Meaning that each one of these partitioned pieces is equivalent to 1 centimeter. So right here, that is 1 centimeter. And if I take and shade in one of these, my fraction would look like 1/100th. However, if I shade in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have now shaded in 10/100ths. And if we drag this back up, I have shaded in 1/10. And to show that in decimal form, I have shaded in 0 ones and 1/10. Not too bad. If I go to something like this, same idea, but this time I'm going to shade in 1, 2, 3. I'm going to shade in 3 out of the 100. So I've shaded in 3 centimeters. 3cm. I bring up this tool that we're used to. And now I see that I have shaded in 3 centimeters, but I have not shaded in 1/10 yet. So I don't have any tenths. So I've shaded in the fraction 3/100ths. And to write this in decimal form, we have not shaded in one whole piece, so we have 0 ones. And we have not shaded in 1/10 yet, so we don't have any tenths. And we've shaded in 3/100ths. That's where this 0 comes in with the 100ths, because we have not shaded in any tenths. Up here we have shown that if we had 1/10 shaded in, we have a digit in the tenths place. We jump down here, we've not shaded in any tenths. So we have no digit in the tens place. We could also break up a fraction like 25/100ths using these tape diagrams that are partitioned into 10 and 100ths. 25/100ths is written as a decimal in decimal form. We have 0 whole pieces, so we have 0 in the ones place, a decimal point, 2, 5. That's how it's written in decimal form. And to show that as a visual, we can take our tens down. And what this tells us is that we have 2 tens, so we can shade in 2 tens, and 5/100ths. So that next 10 needs to be partitioned into tenths. And we shade 1, 2, 3, 4, 5. So as a decimal, 0 ones, decimal point, 2 tenths, 5/100ths, we have done, if we were to write this as a number bond, we have shown 2 tenths and 5/100ths. Now we could do the same. Let's do one more with, I don't know, 31/100ths. Now we know that in 31/100ths, or 0 whole pieces, a decimal point, 31. In that, we have 3 tenths and 1/100th. So if we were to make a number bond for it, it would show 3 tenths and 1/100th. Using our tape diagrams here, we can show 3/10, 1, 2, 3/10, and 1/100th. So understanding that decimal place value, that at the beginning of it, we can show 1/10 as 0 ones and 1/10, carrying that knowledge over into hundredths, knowing that, keeping in mind that this was all just a meter stick, 1 meter equals 100 centimeters, so 10 centimeters equals 1/10 of a meter. 10 centimeters equals 1/10 of a meter, and 1 centimeter equals 1/100th of a meter. We can then begin to understand that when you are posed with, here we have 3 centimeters, so that is 3/100ths of a meter. 3, we don't have any tenths yet, so we need to represent that there are 0 tenths. We haven't shaded in that many yet, and there are only 3/100ths. If we were to look at something like 25 centimeters, we have 2 tenths that we could shade in, and an additional 5 centimeters. So we could have 2 tenths and 5/100ths.